How can you build a foundation as simply as possible, for the lowest cost, and with minimal physical labor? In this video, we're going to show you exactly that, constructing a simple, shallow-depth ribbon foundation with our own two hands. We'll cover everything from choosing the technology and the detailed construction process to the final budget breakdown at the very end of this video. If you're visiting our Creative Galaxy channel for the first time, let me explain. My wife and I are helping build a small budget-friendly house for my parents, as their large old home no longer suits their needs. The house we are building is about 650 square feet, 60 square meters. We'll be constructing it using AAC blocks, aerated concrete. Every single stage of the process will be shown step by step in our videos. This is already the second video in the series. The first one was all about finding and purchasing the plot of land. We are building this house entirely on our own, and for my father, the most important criteria were keeping it on a budget, ease of construction, and of course, speed. At the start of the build, my father purchased the AAC blocks, but we'll talk about those in the next video when we start raising the walls. We also brought in some old wooden slats and beams that I had left over from another project, a boat shed. And naturally, we couldn't go without the most vital attribute of any construction site, the temporary outdoor toilet. The foundation work began with marking out the site. My father decided to position the house closer to the front roadside, so we have more space in the back for a garden and a vegetable patch. We drove 4 stakes into the corners of the house. We measured their positions using tape measures, and I checked the diagonals using the Pythagorean theorem for a right-angled triangle. The square of the hypotenuse equals the sum of the squares of the other two sides. Checking the diagonal this way is much easier than trying to compare them against each other. After that, using those stakes as a guide, we stretched our string lines. For each line, we drove 2 separate posts into the ground. This way, the posts stand off to the side and don't get in the way in the work zone while we set up the formwork or dig the trenches later. On these 8 posts, we marked the starting 0 level using a water level. This is a reference horizontal level from which we later set the height of the formwork. We determined the formwork height by looking at the highest mound of earth near the house. This allowed us to pick a foundation height where water couldn't possibly rise above it, thanks to the slope toward the road. Now, any normal builder would start by digging the trenches. However, we did things differently and started by assembling the formwork. Our formwork isn't tall. It sits about 8 inches above the ground. It seemed more logical to me to assemble the formwork first, and then dig the trench for the shallow depth foundation inside it. In our case, the foundation goes into the ground about 16 inches. Digging the trenches inside the formwork is no problem at all. In fact, it's much more convenient, because you can use the formwork itself as a guide. Plus, assembling and mounting the formwork panels is much easier on solid ground, without trenches, which prevents the edges of the trench from caving in. Assembly of the formwork should start with the outer panels because they set the correct external geometry for the foundation, based on the string lines. We laid out all our 1x4 boards, which were 15 feet long, around the perimeter and began assembling the panels. We fastened the boards together using wooden 2x3 blocks, and for the length, we joined the boards using a scrap piece of the same board. I assembled the panels using 2-inch wood screws. If you use nails, the panels end up being flimsy and require extra reinforcement. You shouldn't drive stakes too close to the panel, because once the trench is dug, they won't be able to carry the load. Stakes should be driven about 20 inches away from the trench. There, the soil remains undisturbed and holds them firmly. The stakes should be placed opposite the panel's connecting blocks and joined with 2 horizontal beams. One goes horizontally, and the second is at a slight angle. It's with these 2 horizontal supports that the formwork is accurately set into its place. The number of stakes and the distance between them should be chosen individually, based on local conditions, soil density, formwork height, and its overall strength. In our case, I drove stakes about every 3 feet. The number of stakes and the overall strength of the outer panel will guarantee the correct geometry of your foundation. Precise geometry on the inner side of the foundation isn't really necessary, so I made it using just 1 board, trying to set it more or less accurately only in terms of height. To secure this board, one cross slat was enough, under which we placed a block to set the height. In the end, the formwork looked like this. Digging trenches along this kind of formwork is a pure pleasure. You might have noticed that I didn't reinforce the inner and outer corners with extra stakes. They already have enough inherent strength to withstand the pressure of the concrete. Once the formwork was finished, we started digging. All the earth removed from the trench was used for the interior backfill. We used that same earth to pack around the outside of the formwork, so that concrete wouldn't leak out through the bottom gap. Even though we don't have a foundation yet, at this stage it's wise to think about insulating the plinth, which we'll do with expanded polystyrene, XPS. The foam will stand inside the formwork and act as insulation for the stem wall. To make sure it sticks to the concrete during the pour, you need to make grooves in it. We'll cut these using a router and a dovetail bit. It's cone-shaped, with the wider part at the bottom. This creates recesses that the concrete will grab onto, so the foam has no chance of coming loose. I should note that we didn't use regular styrofoam, but extruded polystyrene. It's moisture resistant, so it maintains its thermal insulation properties well in the ground. This way, you can easily insulate the plinth for the entire height of the foundation. The polystyrene was secured with screws to the top of the formwork, while at the bottom, the foam sheets simply rest on the ground. We added about 4 inches of sand to the base of the foundation and compacted it with the most accessible tamper available, our own feet. For tying the rebar, I decided to make a simple tool, a tying hook. This device is meant to speed up the rebar tying process significantly. You fold the tying wire in half, pull the free ends through the loop, insert the hook into a drill, and snag that loop. The spinning hook tightly twists the wire, pulling the rebar together, and the cone-shaped end of the hook makes it easy to pull out of the wire. My hook didn't turn out perfect, since I didn't have a vise on site, but even such a primitive version really sped up the work. In our area, the days of foundations without rebar are long gone. Modern monolithic reinforced concrete foundations don't just serve a load-bearing function. They also strengthen the walls, acting like a bond beam. That's why we considered having rebar in the foundation absolutely mandatory. The rebar makes it more solid and resistant to tilting or settling. We didn't do any specific engineering calculations as there isn't strict control over private construction in our country. Like most people, we relied on the experience of similar houses already built in our region and chose to reinforce with 4 strands of 1/2 inch rebar. In my opinion, this reinforcement, combined with the concrete ribbon section of 16 by 24 inches, is more than enough for a small 2-story AAC house. To be honest, I wouldn't recommend taking my figures as gospel. This is a budget private build, and we are taking all the subsequent risks ourselves. If any errors in our technology show up later, we will definitely show them to you, along with the ways we fix them. If your construction budget isn't under strict limits, it would be better for you to consult with specialists for your foundation calculations. The rebar works best if it's placed close to the edge, about 2 inches away. To fix it in place, we used 5/16 inch rebar, bent into rectangles. To prevent these rectangles from sinking into the ground, we attached slats to the bottom and then placed them all in the trenches. A spacing of about 5 to 6 feet between them seemed sufficient to us. The 1/2 inch rebar is quite easy to bend. We bent the 20-foot pieces roughly in the middle and then laid them in the trenches. This way the rebar at the corners was continuous. Then we fastened it to the rebar cage using tying wire. After tying the rebar, we screwed additional slats across the top of the formwork. These connect the 2 formwork panels together and give them extra strength. We also preformed an exit hole for the sewage pipe by inserting a piece of larger diameter pipe. Before laying the concrete, we soaked all the sand thoroughly with water. This made it denser and ensures it sucks less moisture out of the concrete itself. We ordered ready-mix concrete. Of course, you could make it yourself in a mixer, but the savings would be minimal. Calculating the amount of concrete is simple enough. Take the cross-section of our ribbon, 0.4 by 0.6 meters, and multiply it by the perimeter of the foundation, 23.5 meters. We get about 7.3 cubic yards, 5.6 cubic meters. If we don't have enough concrete, we'll have to pour it in 2 stages, which will affect its integrity and ultimate strength. so we ordered about 10% more concrete, almost 8 cubic yards. We used mixed concrete, 3000 psi. This is one of the most common grades for foundations. Ready mixed concrete of this grade is actually very thick, and it's almost impossible to pack it tightly by hand without a vibrator. So we made a compromise and diluted it slightly with water. Yes, this reduces the strength of the concrete, but we tried to find a balance. Either get concrete that doesn't coat the rebar well and leaves air pockets, making the whole structure weaker, or dilute it with water to make it more workable for pouring. This will decrease the strength of the concrete itself, but the overall strength of the structure should be higher with this kind of placement. The mixer driver actually missed the mark with the amount of water, and we ended up with concrete that was runnier than we expected. But we hope this unfortunate fact won't significantly affect the final strength of the foundation. Time will tell, and we'll share the results with you. Obviously, pouring such concrete is quite easy, and we handled the job in less than an hour. In the middle of the house, we also poured a small section of concrete that will support a load-bearing column. Any excess concrete was poured nearby. Later it will become the base for a terrace. After the mixer left, we vibrated the concrete as best we could with a rod to try and drive out the air and excess water. 2 weeks later, we came back to strip the formwork. By feel and impact, the concrete seems quite strong. Let's hope that's the case. However, in some places, hairline cracks appeared along the rebar. They likely formed due to concrete shrinkage during curing, as the concrete was too water saturated. Now, let's run through the budget for this stage. From the previous stage, buying the plot and paperwork, the budget was $2,350. For the foundation, a total of $570 was spent, which includes concrete, rebar, lumber for formwork, and minor expenses. My father also bought all the rest of the lumber for building the house, and some of it has already been delivered. That lumber cost another $500. We also ordered the drilling of an 80-foot well for drinking water. The well with a pit, plus two 32-inch concrete rings for the caisson, plus a cover, cost $171. During this period, we also installed the septic system. The pit for the septic was dug by hired workers, and with 3 5-foot concrete rings plus a concrete lid and a manhole cover, it cost another $270. And of course, the toilet cost us $77. Couldn't go without that. For this current construction stage, the total expenses for the house came to $3,938. I must clarify that all these prices were current for Central Ukraine in 2018. That's when we were building this house, and now I'm telling this story from the past. Be sure to write in the comments how much your foundation cost and what year you built it. The next video in this series will be about building the walls with AAC blocks. Speed up its release by hitting the like button on this video. And if you enjoyed our content, subscribe to our channel. Creative Galaxy, building a life with our own hands. See you in the next video.